My name is Siegfried Vösel. I moderate here and guide you through the session. Cinema has passed in the last decade a lot of transitions, mainly of course from analog to digital, but we have seen that there is a much more request for more immersive experience in the cinema, because at home at least we also have a good experience. And for this reason it's of course important to set up good theaters and also to have a good viewing experience. And I'm happy that we have now 3 presentations within this session where we show from planning of theaters up to the real projection at the screen what can be done today and in the near future. And I hope you will enjoy this, let's go through this quickly. So we have one presentation for a simulation of theaters in a VR environment. You may have heard yesterday that also the NASA is planning for a Mars mission to use some AR glasses for detecting, let's say, failures in the space shuttle. And of course, you can use also VR and AR headsets for simulating of theaters. This will be the first presentation. The second will be for variable frame rates to get a better natural impression what movies can look like, and so you can change between different frame rates. And the third, of course, will be also very important, the question, what contrast can be achieved in a theater, and what is the possible quality in a theater. But let's jump directly to the first presentation. The first presentation is called VR Theater, a virtual reality-based multi-screen movie theater simulator for verifying multi-screen content and environment. The authors are Kyung-Yan Lee and Cho-Sung Min. So the Kyung-Han Lee is currently a team manager at Kai Incorporated. He received his master degree in the Graduate School of Culture Technology at KIAST. He received his bachelor degree in industrial design in 2011. His research interest includes stereoscopic visualization and video codecs. Cho-Sung Min is from the Sogang University Graduate School and has his PhD. He's in the moment Korean Film Council Standard Development Team Manager. Please welcome Cho-Sung Min. He is the speaker of this presentation.
Good morning. My name is Cho-Sung Min, and today me and Kyung-Han Lee are here to present VR theater in this presentation. Immersive movie viewing theater has led to modern cinema such as ScreenX and Barco Escape, where the system utilizes not only the main screen, but the side wall to project additional content. Subjective assessments for these movie theaters were conducted to find presence and visual discomfort in the multi-paced screening environment before this paper was presented last year, 2016. While conducting this test, it was found that it was inconventional to test. Different test studies to verify certain standards. In order to do this virtual reality-based movie theater was developed, my co-researcher Kyung-Han Lee will be giving you more detail on this presentation.
Hello. So before we move on, let me show you a short video, but I think you've already seen it while we were preparing.
Pirates had infected the seas for generations, so I thought to eliminate them all. Then there was this boy, Jack Sparrow. I will have my revenge.
An army of dead are coming straight for you, Jack.
pirate's life. There's nowhere to hide.
How do they do this?
So you've just seen a 30-second trailer of the latest Pirates of the Caribbean movie. As you can see, this is the multiple screen system where we utilize the side walls to project additional content. And as you can see, there's several factors that affect this experience, such as the resolution, the frame rate, the aspect ratio, the masking, and several factors. So this is the system in a large diagram. So we use several calibrated projectors to project to the left and right side of the walls in the theater. And we call this the wing content and wing walls. So VR-based theater simulators are already in the market, but it restricts users from modifying certain aspects of the cinema and are limited to ordinary theaters. They don't support multi-screen system. VR technology allows users to create unexplored solutions in such domains. And our VR theater provides a set of tools to fiddle around several parameters on the multiple screen system to test out certain aspects of various movie theaters around the world. So as I mentioned before, there's very different kinds of movie theaters all around the world, each vary in dimension, depth, height, and width. And they have different setups as well. Meanwhile, as most of you know, virtual reality is being used in the medical industry, in the simulator industry, and also a person can move around his furniture in his room as well. So the technology used for VR theater was the Unity engine, the HTC Vive media recorder, and the HMD of choice was the Oculus Rift. Unity is one of the most popular game engines right now. It supports multiple platforms, from mobile phones to consoles and OS. And it supports for high-end virtual reality devices. There's a whole library dedicated just for virtual reality. And it has an undistorted wide view mirroring feature, which was critical in our system, in our VR theater. HTC Vive Media Decoder is free, and it is a very high-performance video player. It has a lot of FFmpeg libraries, and it supports up to 3 Vive Media Decoders, which was apparently used in our theater. And when we were using Unity, we had to convert the videos into OGG format, but this was having crashes, so we had to use this one. As for the Oculus Rift, it is very high quality and high performance. It has very few cables, so it's very fast to set up, and it provides an Xbox One controller, so you could have interaction within the VR theater. And also has a room scale mode where the person could be wearing the HMD and move freely around the room. However, since our application was a seating experience, we didn't really use this function. So adding video content within VR theater is very simple. It supports most of the popular formats, the MP4, AVI, MOV, MKV, OGV, WMV. And it's simple as you just add the 3 different files to the corresponding folders, left, center, and right. And this should be sufficient. Also, we have an XML file format that uses the data to generate the room. You can have up to 15 theaters, and each theater is added as a new entry in the theater selection scene. The parameters that we used were theater width, depth, height, screen width, screen height, screen color, number of seats, seat pattern, screen to seat, and slope angle. I will be giving you more details on this. So this is the scene where you first launch VR theater. There's going to be a selection of different kinds of theaters, and you can rename them as you want. The middle is where the person is gazing. So you could change the content that you want to see with the Xbox One controller. And once you do a long press, you would be transported into the VR theater. We didn't use very fancy content, but just to test out several factors, we used this content. So the process to generate the theater is you have a selection of theaters from the theater list XML up to 15, and then the container box will be making the 3D environment with width, depth, height, and slope angle value from the theater list XML, and it will then populate the theater with walls, stairs, speakers, projectors, screens, and emergency exit signs. So the center screen, we use the screen width and screen height and screen color value, 1 for white, 2 for silver, and 3 for pearl, since we have different kinds of materials for the screens. And what's interesting is that we render the center video and a render texture, and get the average color of the screen that are then set to spotlights in the screen to simulate light being reflected, just like an actual theater. The wing screens are created using default values from the depths and height values of the theater XML. And we give an option where they can edit the position, scale, and masking. And we use low polygon 3D models for performance issues. And seat pattern mentions is where the space is between the seats, if it's whether on the left and right or the center, or we have 5 different patterns to assign this. And the distance from the front seat, the very first front seat to the screen varies as well, so we also use that value. And we add small green lights for the exit signs. We also have some immersive elements that actually make it actually look like a theater, like the projectors, which emit small light, speakers, and ceiling lights, which can be turned on and off within the VR theater as well. The performance, building the scene should be fast, and the user should not feel a low frame rate while watching the movie. So we optimized this using Unity tools and profilers, and we found out that even with some dynamic lighting, we were able to keep a very smooth frame rate, above 60 frames per second. Like I mentioned above, we had some UI elements where the user could make some real-time adjustments, such as selecting the seat which you would want to watch the movie, change the position and scale of the wing content, and also mask out areas for the wing content, just in case projector light enters moviegoers' eyes, just like it's doing right now. And then finally saving the settings so you could use it at a different time. So the real-time controls include pausing, resuming, restarting the video, resetting the position, and video selection and navigation between scenes, and works well with both the controller and the keyboard. However, we were only able to do the real-time adjustments using the mouse so far. So for the real-time controls, you can, as mentioned before, the video is paused right now, but you can resume it again. For the seat selection, you can open the seat selection, and choosing a seat will teleport you to the according seat, so you could find out how it looks like on different seats. This was very critical since the people sitting in the front won't be able to view some portions of the content being projected behind. So we had to test that out as well. So also the editing the content's position and scale was also provided, the position and scale for the X and Y values. And we also added a sync mode where they could just modifying one screen, one side of the wall would duplicate it to the other side as well. Finally, we provided a function to create the mask to mask out regions where people weren't there. Setting all values to 0 would be projecting the entire content, and setting all values to 1 would be masking out the entire region. And finally, we could save each settings and created an XML file for each theater. And it would be automatically loaded when entering the VR theater once again. So for future improvements, we currently use the HTC Vive media decoder, but Unity has released a built-in native player, so we shouldn't be able to use the Vive media decoder. We want to extend the customizable data to also adjust brightness levels, and as you can see, this screen has a slight bending radius, but we could add that as well. And more visual options, for example, the materials of the walls, if it's fabric or tactum or concrete or so on and so forth. And for the graphical overhaul, use better models and textures while keeping everything low poly for performance. And maybe a better user experience for real-time editing. And finally, create right now, everybody, the user types in the values on the XML file format, but maybe create an external software to make the theater data editing more user-friendly. Yeah, so in conclusion, we have developed a VR-based multi-screen movie theater simulator for verifying multi-screen content and environment. And we hope that this system will provide aid to researchers and content creators, a tool to provide guidelines when creating movies and also applying them to these special theaters. We provided various functions to experiment on different kinds of movie theater settings, and editing functions for when content have also been provided. And we are looking to add additional customizable parameters such as brightness and bending radius for the main screen as well, and maybe added the number of speakers and projectors being used.
Another slide?
Yeah, it's a thank you and FAQ slide, but yeah. Okay.
Okay.
Yes, question. Yeah, thank you.
Your own question. So you have the simulator for multiple screens. What kind of content you will typically show on such screens? Do you would use regular content and then stretch it or cut it, or?
We would be using regular content, and for example, we would be projecting 30 frames per second content on the left side and maybe a 24 frames per second content on the right side, and see if the users could feel the difference or different kind of resolutions for each walls, and see how it affects the user, if they are actually feeling, noticing the difference on the resolution. So, yeah.
Okay, but this is for experiments.
Yes,
for
yes.
a real simulation. So would you take a trailer or feature movie and then split it to the different screens, or is...
That is also possible, yeah. So,
okay.
Yeah.
So what are the limitations today? Is it more the resolution of the VR glass? Is it the audio or...
Yes, very good point. So right now the limitation is that we can only simulate as much as the HMD's hardware capability. So we cannot test content above the required specifications of the HMD. So yes, hopefully that would get better in the future. We will have better HMDs in the future.
Okay. So, yeah, there's a question.
Yes. What about the moviegoers? So populating the area with other people. Yeah, we will maybe add a function where there's actual people as well.
Okay.
Thank you.
One other question from my side. How do you manage to synchronize the different videos in the simulator? Is it built into the VR system, or so you mentioned that you use 24 frames or 30 frames per second, and if you have on all of the screens different frame rates or even the same frame rate, you have to make sure that they are in sync. Or
Yes. For now, we publish it again. So the video, if it's in 6 frames per second, we make that video and then convert it to a 30 frames per second video.
okay.
And then test it out. So yes, we don't. Yeah, I don't know if. That's
Okay. So any other questions? Yeah.
Oh, yes, we currently do have audio in the simulator, but while we were recording, we didn't have content with.
And does that model the in-theater audio? So if it were a 5.1 or an Atmos or
Currently, no. We just have, I don't think we model a 5.1 or 6.1 channel audio right now.
So will it also be a binaural rendering, or will it be independent of the direction or the position of the viewer?
It would be dependent on the position of the viewer.
Okay.
Yes.
Yeah.
Hi, great presentation. For Kingsman 2, we made available content with CGV, and unlike the Barco escape example where they're actually front-facing right screens, we actually have the regular fabric.
Yes,
here.
yes, yes.
Do you have any texture mapping plans, as well as part 2, because of the scenes of the projectors, you actually have overlap. So mechanisms of basically handling that.
Yes, very good point. The ScreenX system that CJ-CGV is producing right now uses various different kinds of materials for the left-hand side walls, like tactum, fabric, or concrete, and so on and so forth. But we have not simulated this particular function in our VR theater right now, but we do have plans to add different kinds of materials, so people can check how it would look like on different materials.
Okay. So yeah. Last question.
I know that historically in systems such as Cinerama, there was concern about light from one side of the screen affecting the image on the opposite. Is there anything involving that, say, in terms of light from the left screen affecting the image on the right?
Very good point as well. We do simulate the lighting being reflected from the main screen as well as the left and the right side screens. So we get the average brightness of the walls and make a spotlight. So it would be actually reflecting, it would be looking like it would be reflecting to the side walls and other places.
Okay, thank you very much. I think we are now out of time. Yeah, please give him an applause.